Good afternoon, everybody, from NASA's Johnson Space Center here in Houston, Texas. I am Josh Byerly. Coming up on Tuesday, Karen Nyberg, Luca Parmitano, and Fyodor Yurchikhin are going to launch toward the International Space Station and join Expedition 36 in progress on the orbiting complex. There is quite a bit of operational activity ahead for this crew, as well as a ton of science is going to be going on over the next several months. Here to give us more details about what's ahead is Mike Suffernini, the International Space Station Program Manager, as well as Gary Horlacher, who is the lead flight director for Expedition 36. And we're also joined by Tara Rutley, the Associate Program Scientist for the International Space Station. We're going to hear from each one of them, and then we'll take some questions. We'll start with Mike.
Well, good afternoon. Of course, with the return of Tom, Chris, and Roman, we began Increment 36 on board ISS. The vehicle's in great shape as we continue to do research on board. Last week we changed that, well, not last week, a couple weeks ago now, we changed out a pump on the 2B, or the port outboard solar array cooling system, and that seemed to be the source of the big leak that we saw. So we today finished transitioning all the loads back on that particular power solar array, and everything is configured in a nominal fashion as we proceed forward. The other big thing going on system-wise today anyway is our Russian colleagues who have been using a U.S.-developed treadmill we refer to as TVIS. It's a vibration-isolated, one of two vibration-isolated treadmills on the International Space Station. They're busy replacing the TVIS with a Russian-built treadmill. That work is going on now, and they'll begin testing here shortly. That's a big event for us as well. Research-wise, though, the teams have really been focusing on making sure, while we continue to maintain the systems on board, that we get a number of hours for research. The prescribed number of hours, of course, is an average of 35 hours a week. And over the last several increments, we have been beating that number by a good margin. A little bit later, Tara will spend a little time with you talking about some of the research that we plan to do on Increment 36. Now, Increment 36 is going to be one of the more challenging ones for us to continue to provide the 35-hour average because of the fact that there are 5 EVAs during this period. Part of it goes into Increment 37, but while this crew is on board, we'll have about 5 EVAs. They're really geared towards the next major module to come to the ISS, which is the Russian MRM module, which comes up in the December timeframe. And so EVAs by themselves, of course, are an impact to crew time. In addition to that, we'll have the first, it is a plan anyway, to have the first orbital flight to ISS, the demo mission, which right now we just recently slated for a launch on September 12th. And so that's in our plan as well, which will keep the crew busy. And of course, during this period, as soon as the crew arrives, we have an ATV arrive. Then towards the end of the summer, we have an HTV arrive. And so this will all keep the crew busy while they're also trying to get the research work done. Also unique to this period, which again includes Increment 37 as well, while the crew is on board. Right at the end of the stay for this particular crew coming up will be a unique opportunity for the International Space Station to host the Olympic torch on board. Our Russian colleagues are working with us on a plan that would bring the torch to ISS and then return it on with Fyodor and Karen and Luca on their return. And so we're looking forward to that, because what's unique about that, it's been many, many months since we've done what we call direct handover, where we have actually 3 Soyuz attached to ISS at one time. And this is allow us to bring the torch up with the crew that's arriving, and then let Fyodor and Karen and Luca bring it home on their vehicle a few days later. So it's a very, very busy increment for us. Our plan, of course, our plan still shows that we'll be able to get 35 average hour accomplished, but we have a deficit today, and so that's not uncommon. If you look at the plan, it looks like it'll be difficult for us to do that, but our ops team and engineering guys continually surprise us with their ability to overcome, and so I fully expect us to do all those wonderful things we've talked about for this increment, getting ready for MLM and the torch, while at the same time getting the research done that we built Space Station to do. And so with that, I'll hand it over to Gary, and he'll give you more details.
Okay, thanks, Mike. No pressure. I appreciate that. So good afternoon, everybody. I'm Gary Horlocker. I'm the lead flight director for Expedition 36, which started, as you heard, about a week ago. And I'll continue my lead flight director duties up until the end of the expedition in mid-September, when David Korth, I believe we have a photo of him, will take over as the lead flight director for Expedition 37. And this transition occurs with the departure of the current crew that's on board, and we'll talk about that more in a few minutes. So Expedition 36 began, as Mike mentioned, with the departure of Chris Hadfield, Roman Romanenko, and Tom Marshburn back on May 15th. And remaining on board is three crew members: Chris Cassidy, you see him here, Chris, Pavel, Vinogradov, and Alexander Misurkin. And Pavel is currently the commander of the space station for this expedition. And they've been on board since the end of March. The expedition will be augmented by 3 more crew members here next week. Their arrival on May 28th of Karen, Fyodor, and Luca, and you can see them here. Karen's a veteran spaceflight astronaut. She was a mission specialist on STS-124 back in 2008. Fyodor is our most experienced crew member in this crew complement. He's a veteran of 3 space flights. 2 of them were to the ISS and 1 to the shuttle. He was a mission specialist on STS-112 back in 2002. He was in the commander of Expedition 15 on the ISS, and then the flight engineer on Expedition 24 and 25. And Luca is our European Space Agency astronaut and an Italian Air Force major, and this will be his first space flight. So I'm going to give you a quick overview here of Karen, Fyodor, and Luca's final preparations for launch next week. I think we have a short video to show you here. You see their arrival at Baikonur in Kazakhstan. Some photo opportunities before they get inside their Soyuz capsule and take a look. And they're all suited up prior to another fit check. Here's Karen getting a fit check with her suit and her Soyuz seat liner. And here they are walking out to their vehicle to get checked out. Here's Karen in her seat. They also do several traditions prior to launch there at Baikonur. One of them is tree planting. You see Luca planting his tree here. And so they're well on their way to the launch next week. So they'll continue their preparations the next few days and be ready to launch at 3:31 p.m. Central Time on May 28th, with a docking about 6 hours later at 9:17 p.m. So now I'm going to go ahead and walk you through a quick timeline of the highlights of this expedition. What you're going to see, the theme here is about every 1 to 2 weeks we got a major activity, either a vehicle arriving at the station, departing from station, launching from the planet, or one of these 5 spacewalks. So obviously starting next week on May 28th will be the launch of the 35 Soyuz vehicle with Karen, Fyodor, and Luca on board. And they'll dock to the MRM docking port on the nadir side, or the Earth-facing side of the space station. About a week later, the European cargo vehicle, ATV-4, will launch and start to head toward the space station. Here's a shot of it in its final preparations for launch. Following that, on June 11th, the Progress 51P vehicle will undock from the SMF docking port, which will clear the way for the ATV-4 to dock at that same port on June 15th, just a few days later. And then on June 26th will be the first of the 3 Russian spacewalks, and all 3 of these spacewalks will be performed by Fyodor and Alexander. And this first spacewalk is going to focus on some external Russian experiment work outside the vehicle. A couple weeks later, we'll come into July 9th and July 16th will be the 2 U.S. EVAs number 22 and 23, and our 2 spacewalkers are Chris and Luca for both of these EVAs. And coincidentally, Dave Korth will also be the lead flight director for both of these EVAs, and he'll be back here sometime next month with a detailed briefing on both of those spacewalks. A week later, July 25th, we'll see the Progress 50 vehicle undocked from the DC-1 docking port, followed 2 days later by the launch and docking of the next Progress vehicle, the 52 vehicle at that same port. And then the week after that, we'll get the launch of the HTV-4 cargo vehicle from Japan. And I think we have a picture of actually the HTV-3 vehicle in flight last time it was up. So we got 2 big cargo ships coming to the station there in July and August. So we have a lot of cargo operations to take care of in that time frame. So on August 9th, we'll go ahead and capture and berth that HTV vehicle to the Nadir 2 docking port on the space station. And then we'll step right into the last 2 Russian EVAs of this expedition. That's EVA 34 and 35. And both of these EVAs will continue external experiment work, as well as Mike mentioned, some preparations for that MRM module that will show up later in the year. And that'll lead us into September 8th. We'll hopefully have all the HTV operations complete, and we'll unberth and release that vehicle. And then 2 days later, we'll see the end of this expedition with the departure and return of Chris, Alexander, and Pavel. So that'll kick off the Expedition 37 time frame. Now, Karen and Fyodor and Luca will remain on board through mid-November, and they'll see the arrival of 3 more crew members at the end of September. You see them here. That's Mike Hopkins, Oleg Kotov, and Sergei Rosinski in, like I said, late September. So as you can see, we got our challenges are definitely managing all these visiting vehicles and their associated cargo operations, as well as 5 EVAs with a lot going on just about every week. So like Mike said, it's going to be a challenging time for both the ground and the crew. And on top of all that, of course, we've got a very, very healthy science and research program to deal with as well. So Tara's going to give you some details on that.
Yeah, thanks very much. Happy to be here with you all today to share some of the good things that are happening on the space station regarding the science. I'm the Associate Program Scientist for Station. I reside here at JSC, and our offices have been really, really busy, and our teams have been really, really busy managing the diverse research portfolio that's happening on station. And the crew members have been busier than ever getting it done for us up there. So I want to share with you guys some stats as of today. To date, on the space station, approximately 1,600 investigations have actually been performed across the partnership, and that's representing over 1,500 scientists on the ground across 68 countries. Very busy, and so through the remainder of this year, we'll be looking at doing over 300 investigations total through 2013, and they cover the range of disciplines from biology and biotechnology to human research and physical sciences, education, technology demonstration, and human research. Each of these investigations is going to provide knowledge that advances the human exploration of space, gives us some fundamental knowledge that we can gain to advance our own textbook knowledge, and getting us some new discoveries and benefiting those of us here on Earth as well. Although hundreds of investigations are going to be performed on Expedition 36 and 37, I only have time to talk to you about just a handful of those today. So the ones I'll share with you are actually going to be particularly relevant to crew health and safety on orbit, and they also have Earth applications as well. The first investigation I'll share with you today focuses on a new technique aimed at identifying the best ways to maintain bone health in microgravity. And this is the HIP QCT investigation, which will use quantitative computed tomography, and that's the QCT part, to look at the quality of the hip bone in our astronauts returning from long-duration spaceflight on station. And we really want to use this technology to basically get an idea of how good our countermeasures work on orbit. See, now normally here on Earth, our bones stay healthy and strong by undergoing a constant remodeling process, and that is the breakdown of old bone and replacement of new bone. And so it's constantly happening without even us knowing about it. So the cells you see here right now are called osteoclasts, and it's their job to take down and break away the old bone. And in preparation for these cells that'll come along next, called osteoblasts. And the osteoblasts come along and add back the new bone. And it's this constant process of remodeling that keeps our bones healthy and hold us up against the gravity vector on Earth. Now on Earth, it's a good natural balance, but in space, there are changes in this balance. And so you get what you get as a net result of a loss of bone mass without adequate replacement of the bone mass. So this puts us at a risk of a higher fracture for risk, and so we care about these kind of changes. We want strong and healthy bones. We care about it for our crew members as we stay longer and longer in space, but we also can use this information that we learn from our studies on orbit to help those of us here on Earth that may be dealing with osteoporosis. In fact, astronauts lose bone mass at a rate of about 2% per month in some areas of the body. So it's a big issue for space exploration. It's also a big issue here on Earth. Now, space station scientists have investigated different countermeasures in an effort to maintain bone health on orbit. This includes pharmaceuticals and exercise and proper nutrition. In fact, a recent space station study was published in the Journal of Bone and Mineral Research last fall that's shown that a combination of high-load resistive exercise on orbit, such as what you're looking at here, using the Advanced Resistive Exercise Device, along with adequate intake of vitamin D at about 800 IUs per day, and eating the right amount of calories can help maintain bone mass. And this is a big, big finding for us. So our data has been traditionally collected using DEXA scans of the bones. It tells you something about the bone mineral density of the bone. And this is also used on the ground in patients with to monitor osteoporosis progression. But it doesn't tell us much about the quality of what's going on the inside of the bone. And that's what we really, really want to know about, because we really want to know about the risk for fracture. So it's important to determine the structure of the bone is healthy. So the hip QCT study is underway. It's going to take pre and post-flight measurements of crew members of the hip using the QCT. The QCT is a three-dimensional 3D imaging capability that can tell us something about what's actually happening to the structure and the quality of the bone. QCT is also used here on Earth for osteoporosis monitoring and can tell us details about the different parts of the bone, such as what you see in the image on the right. What we can find out about are changes that happen to the cortical bone and the trabecular bone. Now, the reason we care about these two parts of the bone in particular is because they have to work together to maintain the overall structural quality of the bone. So we really want to know the details of what's happening in maintenance of these areas of the bone. Now, what we're going to gain from this is a good understanding of how our countermeasures are working together to help mitigate bone loss and keep our astronauts protected longer for longer durations. We can also gain and use any of this data that we collect here for understanding what's happening to our disuse osteoporosis or our normal osteoporosis patients on Earth. Osteoporosis affects about 75 million people across Europe, Japan, and America. Another area of importance in keeping astronauts healthy in the future of space exploration is understanding how plants grow. The ability for plants to provide a food source and participate in environmental life support systems can prove critical for astronauts as they stay longer and longer in space. Now, plants have had about 3 to 4 billion years worth of adapting to the environments here on Earth, which makes them really responsive to any changes in their environment. So on the space station, experiments have provided us information about how plants grow when you change things like temperature and lighting and moisture and atmosphere and specifically also gravity, of course. So when we do more work, we need to do more work in understanding how plants grow, and we can put it all together to successfully tell us how we can grow plants that'll be helpful to us on exploration class missions. So a new investigation from our partners at the Japanese Aerospace Exploration Agency, JAXA, will investigate how tiny tubular proteins in plants called microtubules will arrange themselves to direct their plant growth and structure under microgravity conditions. Now, we know that these microtubules play a major role on Earth in helping plant cells reorganize in response to disease and external environmental signals. Now, in the green left image that you can see on your screen, you can see that under normal gravity conditions, these microtubules will arrange themselves transversely in stems as the plant grows for optimal structural support, so they provide structure. But our JAXA scientists have found that plants grown under hypergravity conditions, such as the 3G depiction you see here on the right in green, they'll change their microtubule orientation to longitudinal, and what you get is a shorter, thicker body that's designed to withstand the increased effects of gravity. And this is known as plant anisotropy. And this kind of response is one example of the plant's way of adapting to changes in its environment. Now on station, JAXA investigators are going to look at the resulting microtubular arrangement of Arabidopsis seedlings grown under microgravity conditions. And given what they know, they expect to see an increase in the transverse arrangements of the microtubules along with longer, thinner stems. So we're going to see something a little different. And we care about this kind of result because plants use energy to help grow. And so it's about efficiency of the energy that they use to help themselves grow that we can gain knowledge from and contribute to our database and understanding the entire story about how to successfully grow plants in space. So investigations like this will contribute to plant growth knowledge to help develop sustainable and economical means of human life support in space. And we can learn some things as well that'll help us advance agricultural production here on Earth. The next investigation I'll talk about is the multi-gas monitor. Now, the space station is an ideal platform to advance technology development important for crew health and safety. And so the multi-gas monitor demonstration will get underway during Expedition 37. The multi-gas monitor is the first application of laser spectroscopy to simultaneously measure multiple gases in the internal space station environment. This includes oxygen, carbon dioxide, and ammonia. It'll also measure water vapor or humidity in a real-time, continuous fashion. Now, this kind of portable optical laser gas analysis technology, or OLGA as you see there, is designed to be very selective for particular environmental constituents with a very high amount of sensitivity and accuracy and no environmental cross-contamination. So I actually brought along an engineering unit that I brought to show and tell you guys today. And I know, right? It's always fun when you can actually bring some hardware to show and tell. And so this is an engineering unit. The flight unit's much more robust, but it's designed overall to be modular, battery powered, and actually flexible enough in the future to look for things like combustion products in the atmosphere as well. So if you can see here, it has a display and it gives a real-time reading of the data that it's collecting. So you can see the water, the carbon dioxide, the ammonia. It'll collect data on ISS while housed in a rack, and then also crew members can take it around and make it portable and test certain areas of the ISS as well. And then that data will be compared to environmental data that's collected from the existing ECLIS systems on orbit and just kind of see how far this technology can go. You all in the room are welcome to come up after the briefing and test its capabilities as well. You're invited to come up here. What I wanted to add for this is this kind of multi-sensor capability has really good use for potential on Earth in areas such as personnel and health and personal safety and health monitoring in industrial plants, atmospheric research, pollution monitoring, and even food quality assurance. The final investigation I'll tell you about today is actually wrapping up during Expedition 36, and this is the BASS investigation. Now, BASS stands for the burning and suppression of solids. So we have a flame investigation I'll talk about. So you know, combustion experiments performed on station tell us not only about how to keep our crew members safe, but it also gives us data for Earth-based models that drive improvements in the designs of fire detection and suppression systems on Earth. So what you're looking at in this graphic is some examples of flame behavior we see in space. And in general, we've learned that in microgravity, without the buoyancy-driven convection, flames will burn at a lower temperature at a lower rate and with less oxygen needed than in normal gravity. We've also learned that even smoke detection times are longer in space because of the different burning characteristics in the microgravity environment. So the space station is a great place to do all kinds of combustion experiments using different fuel types, different means of detection, and different types of suppression methods. Now, the BASS investigation's been looking at the effects of burning various solid fuels inside the MSG, and it burns fuels such as acrylic, different types of plastics, and cotton. And these different fuels will be of different sizes and shapes, and then we'll test them out under different atmospheric conditions with different suppression techniques. So what you're looking at here is Chris Cassidy showing us a sample of what one of the solid fuels looks like before it's burned. And then you'll see Don Pettit performing the very first BASS test on ISS. This is a test in particular that's burning a composite fabric of fiberglass and cotton in ordinary ISS air. Now the airflow here is from right to left. And the investigators are watching for changes in flame color and size as the airflow is varied. The goal of this particular test was to determine the effect of airflow speed on the flame spread rate and extinction. And we're real excited to learn about the data that we get from this study, which will contribute to the combustion models used in the design of future fire suppression and detection systems, both in space and on the ground. And while this set of BAS objectives are wrapping up, we're looking forward to next year when we'll see BAS 2 with an increased number of types of fuels, an increased number of investigators, and an increased number of test points. And all of those things will contribute to even larger, more complex combustion investigations for solid fuels. So to sum it all up, we have some really neat and interesting and unique science happening on the station during Expedition 36 and 37. You can learn more about these and all of them that are happening on 36 and 37 if you go to nasa.gov and visit the press kits. We're looking forward to working with the crew on this. We're real excited. I know they're real excited. And it's real important research that we'll be able to perform throughout the year. That's all I have.
Okay, thank you, Tara. Let's take some questions now. We've got the news media here in Houston, as well as some special guests that are here as part of the NASA Science Social, and we've got some media on the phone as well. So we'll start over here with Mark. Do you have a question?
Yeah, thank you. Mark Carreau for Aviation Week. I have a couple of questions I think that are primarily operationally oriented, and the first has to do with the developments today. I think you put the 2B power channel back in the mix, and I'm just wondering if is your leak chase sort of settled now, or will you continue to monitor the P6 solar power module to see if there's still a leak of some kind out there?
Let's see. So P6 is basically had a leak since early in its life, and in fact we've refilled it once already on orbit, which is something we'd planned for. Small leaks that you can't find, we just refill every so often, and it goes 4 or 5 years. That leak rate increased a couple years back, I think, to a slightly higher leak rate, but not one that was alarming. I think it went from about 5 years to maybe 3 to 4 years. And then right before the holidays, the Christmas holidays, if you recall, the leak rate increased significantly. We went outside and isolated the radiator on this 2B1, and the leak rate changed to be significantly less, but the radiator was held tight. So then this last leak occurred. It was much bigger. It was 5 pound per day kind of leak. It was a very high leak. And of course we saw the ammonia. So we changed out the pump. That leak rate is gone. But the smaller leak rates, the 2 smaller leak rates I mentioned earlier, it'll take us a couple of months to see, probably a couple to 3 months to confirm that the slightly higher leak rate is not there, and then the small leak rate, it could take us 6 months to a year to really conclude that that's gone as well. So it'll take us a little time to sort that out. But if either of those leaks are still with us, you're still talking years, and that's kind of in our plan to refill this every so often as necessary.
Okay, go ahead.
I noticed that the May 28th Soyuz launch will again be the sort of express transit. Cool. And I wonder is that going to be the routine? Is that still to be determined? I'm just wondering whether that's so desirable now that you can do that each time, or it sort of depends.
Well, what we did, in the end, I think ultimately it will depend. We have not decided as a partnership that that's the plan, the given plan. We have addressed it now on the first flight. We did it as an individual flight. We put in some countermeasures to make sure the crew was as rested and ready to perform the docking event as possible. It went very well. So based on that review and assuming the same countermeasures, we agreed to look at it again. And then in the summertime, we're going to step back based on those 2 flights and our experiences and make a determination and a recommendation to our Russian colleagues about what we plan for in the future. And I suspect there will be, some answer that says, if you agree to do this, when you do it, and maybe not in all cases would you plan to do a 4-orbit rendezvous. So we hope to sort that all out and kind of decide what the plan is for the future after this next flight.
Okay, Robert.
Hi, Robert Perlman with CollectSpace.com, also with a few questions. With regards to the expedited rendezvous, was there any feedback from Chris Cassidy or the other crew members that played directly into any direct changes for this crew in terms of crew comfort or managing the 6-hour compressed schedule?
Well, the biggest comment, first of all, the crews all said it went very well. They were very comfortable. The biggest comment they made was we had started sleep shifting the crew right after they arrived in Baikonur. And so when you sleep shift the crew, you have to sleep shift everybody that's working with the crew. So it's a dramatic impact to the team at Baikonur. And the crew came back to us post-docking and said, you know, that was probably not necessary. And in fact, the sleep shift plan this time really starts the sleep shift after sometime after the second fit check. It's in fact, we're doing a variation to this time. It's more along the lines of you basically let the crew sleep like they normally do all the way up to close to launch day. Then we call it slam shifting. You do a big shift, you give them a nap before launch, and then they go fly. So it's just another technique for sleep shifting that people use because you're very rested when you go to fly. And generally speaking, the nap is a very useful nap, meaning it works. You're able to sleep during the nap period. And so we're going to try this technique. We think maybe next time there's a variation on that theme. So we'll look at different sleep shift plans to see which is best. But the crew really felt like that much of a sleep shift for that long a period of time was not necessary. Other than that, they pretty much confirmed the other mitigations that we put in place. Primarily, probably one of the biggest one after having the appropriate meds available and sleep shifting was to have access to the Bay O and get in there so you can get food and go to the bathroom and do the normal things you'd want to do, stretch your legs a little bit before you have to get back in the seat for the docking sequence. So they largely just confirmed what we did, that it worked very well.
And with regards to ATV-4's launch and Progress 51's undocking, there's been some talk about possible damage given the antennas not retracting. What will be the course of action in terms of your launching, or ESA's launching ATV-4 before Progress 51 undocks? So I don't know if you get a good look beforehand. They're both using the same port. What if that port is damaged? What happens with ATV?
Yeah, I can address that. So the antenna actually failed to deploy as opposed to retract. That's all right. The other time we had an antenna problem, it failed to retract. So it's and if you look at the antenna, it's got kind of a rim area, and then I call it the hat shape where the electronics are on the back. The rim area is very, very thin aluminum with a little white kind of cloth material over, so it's very flimsy. We expected that did contact the outer mold line of the docking ring and is probably resting on this MRR, this retroreflector that the ATV needs to use. But the loads are such that we don't expect that we damage the retroreflector. It is possible, two things are possible have occurred. One is there's some MLI on this outer mold line on this housing around the docking. We don't believe it's come loose as a result of that, but it's possible that it's come loose. The other is, and just in the act of rubbing up along the side of the docking thing, we might have put some contamination on the retroreflector, which would perhaps make it difficult to reflect the right energy back to the ATV when it approaches. So the plan is for undocking of 51 Progress. We have these cameras. They have cameras that look both ways, and so we'll look at the Progress camera as it departs to see if the MLI is interfering at all with field of view. It's a very simple check. And then assuming that doesn't look like it's impeding the ability to utilize the MR, then we'll go ahead and let ATV approach. And in fact, we've already given a go for launch for ATV-4 pending the launch review that they have close to flight. But from a program standpoint, we've said we're good for ATV-4's launch. It approaches, it acquires these targets at about 240 meters. At that point, if it can't get a good reflection back, it'll try for about 90 minutes, and then it'll do an escape. So at no time would the ISS be at any risk. And then at that point, we'll know the MRR was either contaminated or there's some other problem with it. And this crew that's going up is bringing up a spare with them. And so our Russian colleagues will do an EVA to R&R that. Fyodor's actually looked at the R&R procedure, and since he's had a little time with it, so he's familiar. He's probably the one that'll go outside, and they'll just change out the MRR. The ATV will loiter until that's done, and then come back and dock. So that's the plan. We really don't expect there to be any issue, but you know what they say, it's all about the plan. So.
Okay, who else has questions? Raise your hand. Go ahead, over here.
I was curious when you're trying to cycle them into like the sleep shifting process, and you were saying appropriate drugs. I mean, like sleeping pills or melatonin? I'm just curious.
Well, I don't want to get too deep in all that, but we do have different types of medications that we provide, that the flight docs provide to help the crew sleep. There's also medications they can use to help them stay alert. The medications I was referring to, though, is space adaptation sickness is a phenomenon that is widespread in terms of space flight, but it's hard to decide who's going to react to it and who's not. Some people fly, don't feel anything. Some people fly and have mild inconvenience. Others fly and it's a little more aggressive. And so on the ground, we spend some time testing these meds, different types of meds on different crews to see how they react, to make sure that they don't react in a way that would make them unable to do their job. And so they spend some time with each crew member trying different meds to see which ones works best for them. And that's what I was referring to. And then they do that pre-launch, and then they have those meds available for them if they want to take prophylactically before they fly or at the onset during flight. Most of the time, if they have a concern, they'll take it before they fly, so they don't have to wait for it to work for them on orbit. So that's what I was referring to.
Anybody else? Back here in the back.
Can you talk a little bit more about the spacewalks that you have scheduled? Like, are they just, what kind of maintenance or anything are they doing?
You know, I'll let Gary talk about that. He's gonna have to get deep into it. So why don't we let Gary do that?
Yeah, so I'll talk about the 2 U.S. space walks we have planned in July. So now that space station assembly is pretty much complete, you know, back when we were building the space station, we were going outside at pretty much every mission, every few months that we got up there with the space shuttle and built this incredible vehicle. So now that it's assembled, we don't have to go outside very much, except for when issues like that ammonia leak popped up a couple weeks ago, and we went outside and fixed that. So we kind of have a backlog of maintenance items we like to go out and take care of. Kind of like around your house when you take a few months off and all of a sudden you got all this little to-do list you got to go do. So the first spacewalk, one of the things that brought up some hardware on the SpaceX mission a couple months ago that will allow us to repair the radiators if we ever have a problem in the future. They're pretty big pieces of hardware, so we temporarily stowed them robotically outside. And so the first spacewalk, one of the main things we're going to do is go ahead and take those from the temporary location and go get them stowed properly on the truss on each side, so they're ready to go when we need them in the future. Now, you know, one of the other things, we had a failure of one of our high data rate antenna systems a couple months ago. We have 2 of them, so it's just a loss of redundancy on the ability to transmit high data rates up to the vehicle. The downlink side was fine. So that piece of hardware, we're going to swap that out and get that back up and functioning as well. Then we got several other, like I said, miscellaneous items. One of the things we're doing is running some power and data connections down the U.S. segment, and those will be available for our Russian colleagues on their spacewalks to hook up to those for the module we mentioned is coming up at the end of the year. So that's preparation for that new module coming up. The second spacewalk, one of the other things we're doing is, as part of that radiator repair capability, we've got some hardware that's currently stowed inside the vehicle. And as you can probably understand, the amount of cargo we have coming up with all these cargo ships, if we can get a little more space inside. So we're going to take these 2 big pieces of hardware outside and put them in a more permanent location and have them ready for a future repair job if we need it. And then we got one of the antennas that we use for the spacewalks failed a while back, so we're going to go ahead and work on that. And then, like I said, a couple other little things like cameras that have had issues over the years. So again, a lot of it's kind of catch-up work since we really haven't gone outside to, other than for kind of a contingency repair capability in the last year or two. So we're going to try and do a lot of catch-up work.
Okay, let's go to the phone lines real quick, and then we'll come back here. I think we've got Stephen Clark with Spaceflight Now. Stephen, can you hear us? Okay, how about Miriam Kramer?
Hi, yeah, can you hear me?
Yeah.
Oh, hi, this is Miriam with Space.com. So I just have a quick question. Will the astronauts be continuing the research that has already been done on the station about measuring their height using an ultrasound machine? Will that still be an experiment that's done during this expedition?
Oh, sure. Yeah, that's an ongoing investigation looking at changes in the spine. They do use the ultrasound for lots of different types of investigations, looking at the heart, looking at the spine, looking at the eye, changes in the eye. So yeah, it's going to be continuing and ongoing.
Great, thanks.
Sure.
Okay. Let's try Stephen one more time, see if Stephen's there. Stephen, can you hear us? I think we may have lost Mr. Clark. Okay, let's come back here to Houston. Who else has questions here in the room? Here in the front row.
Can you potentially tell me a little bit about any meteorology observations going on at the ISS, either planned or currently going on?
Do you have any in mind in particular?
Well, I saw earlier like a graph of ozone distributed, things like that.
Oh yeah, there are a couple. There are a couple of external facilities that are on station that look at lots of different things, changes in the coastal ocean imaging using hyperspectral capabilities. There are, a whole slew of DoD sponsored payloads looking at changes in the atmosphere, changes in plasma, changes across the board. So there are lots of different payloads. There are future capabilities that are also up and coming that are looking at the atmospheric aerosol changes, looking at zooming in a lot more closely on the climate changes. Look for an investigation called CATS. Look for there are a couple other larger ones that are going to be permanently mounted on the external truss of station in the next 2 to 3 years. Our external facilities capabilities for Earth observation are really, really ramping up beyond what we have already had. So there's a wide array. Yep.
Okay. Who else? Right here.
Do any of the other power units have noticeable ammonia leaks?
Simple.
I'd like to give you more details, but there are no more details to give you.
We like that answer.
Yeah, we do like that answer.
Over here in the front row.
What kind of plants are you growing, and why did you choose those?
For this particular investigation, they're going to grow Arabidopsis, which is a mustard-type derivative of a plant, and they're going to sprout these from seedlings. And they choose Arabidopsis because it's a model plant. They know a whole lot about the genetics, the phenotype, the way the plant grows here on Earth. And so once you know that about a particular organism, it becomes the model organism by which you can compare the changes that you see. In the biology world, the C. elegans, the worm, is the equivalent of the model there. So yeah, that's why we chose Arabidopsis. There's a whole, in most of the investigations will use Arabidopsis. Other investigations, though, if you're looking at food crop, we've done radish and tomatoes and just run a whole gamut. And the trick for plant growth is to be able to get something that goes from seed to seed stages. So you want to be able to make the whole cycle so you can prove that the plant will be useful on orbit. But for these kind of scientific investigations, the Arabidopsis is the model of choice.
Over here. Any more on the left-hand side? I thought I saw a hand. Back over here, right here in the middle.
Hi, I was wondering if there were any pharmaceutical investigations going on with the bone density or the bone remodeling that you guys had going on.
That's a good question. So there have been a number of them. Bisphosphonates is one that they're looking at. Crew members can choose to sign up for these to implement on orbit as well. So bisphosphonates, one potential countermeasure. There have been other pharmaceuticals tested in rodents in the past, looking at osteoprotegrin, myostatins, and products that are commercially available and used in patients in osteoporosis here on the ground. Pharmaceutical-wise, though, I think bisphosphonates is the only one that's going on right now.
Okay, over here.
What are current plans for testing with the Robonaut 2 device that's on the space station right now?
Well, Robonaut 2 has a task board on orbit, and so the goal for Robonaut 2 is to test its tactile functions and capabilities by programming either from the ground or by the crew members who are already on orbit. So Robonaut's got this task board that has lots of different capabilities to draw out some of the strengths and weaknesses in the tactile function and operations. I know that there's some discussion in the future about expanding the Robonaut capabilities to perhaps have legs, is what I'm hearing, and maybe an external, an EVA mounted Robonaut as well. So once we get through these first couple of rough technology demonstrations and get really comfortable with the progress, it's going to become a more complex design.
Okay, over here.
Back to the meteorological stuff, you were saying that you're going to be ramping up stuff there more in the next couple of years. Is global climate change and like extreme weather encouraging this sort of, I mean, is that part of what that's about?
I don't think it's a reaction to that necessarily. I think it's just a reaction to the community recognizing that we have the capabilities and the access to the capabilities. And there's always an interest in climate control. There's been for years. And so I think it's not really a reaction to latest news, but more of a reaction to the availability of the facilities. It's a good question.
Over here.
Do the astronauts get any exposure to the sun through the windows? And do you know if both types of UV rays come in through it?
I don't think they get any kind of exposure of not through the, well, hang on. There's some kind of radiation levels inside the space station. That's a really good question. We have lots of different types of detectors inside the station that are different types of technologies. We're testing out the best one of those that could be potentially used on future long duration missions. The vehicle, but even that's a challenge because the vehicle is so well designed to protect the crew against the radiation that, you know, and it varies by module and by location inside the vehicle. So we strategically place those detectors in places where that are pertinent to the measurements that we want to take. But there's all kinds of different measurements inside. Yeah.
And there's UV.
Yeah, UV.
There's UV protection on the windows on the U.S. segment. There's a couple of windows on the Russian segment that don't have that, and so well, first we don't encourage crews to use them very often, and when they do use them, they wear sunglasses. And actually they can use sunscreen too. They don't use the windows very often now that we have the cupola, but in the past they had.
Mark.
Thank you, Mark Careau for Aviation Week, and I think this is for Tara Rutley. You talked a little bit about the research profile from a quantitative sense, and the 35 hours was kind of the mark. Could you dial back maybe a couple of months? I think the last crew blipped over that, and kind of what some of the high points are and what you're striving for now.
Yeah, I think we've seen an average of way over 35 hours a week for the last couple of months, right? Was that 4 or 5 months now? I've lost track, but and they've just been keeping busy, giving us science, getting the data back. Even when we encounter on orbit tricks, it's not been an impact to the science, and our office is always asked first, what's the impact to science? Is very first and foremost, and so it's been a pleasure to implement the research portfolio. Just the high points are getting the data back, getting results that in the form of technical publications in really high impact journals that we can turn around and share with the community, such as some of the results that have come from the alpha magnetic spectrometer recently and Professor Ting, some of the bone mitigation loss results, some plant papers that have recently come out showing how plants respond not only to the gravity stimulus, but also it's critical for light as well, which we suspected, but it's interesting when you look at it from a root perspective, roots waving and skewing. So there's been, the best part of the research is when you get the results, you get to communicate to the community. And you know what, science takes time, and that's just the way it is. So it's not always one big bang highlight after the next. But over the last few months, it's been really great to see that the science has been protected and the crew is able to perform the on-orbit work they need to do and still get the research done.
Let's see, 6 weeks ago? I think it was 6 weeks ago, roughly speaking. A few weeks ago, we'd have to get you exact time, week. we had 72 hours in 1 week. So that was the highest number of hours for research in any week since space station started flying. So that was a big deal. The week we did the EVA 2 weeks ago, we did the EVA, which is always a big impact to crew time. We actually did 42, 43 hours of research. So it's been amazing. Now that EVA was unique. We had basically planned for this EVA as 1 or 2 options back in the Christmas time. We just finished getting the suit checked out, so we didn't have to do a lot of extra suit work. The 2 crew members that went outside had actually been outside. They changed the batteries out on this truss together a few years back. So there were a lot of reasons why this EVA was able to be done relatively quickly and had a less of an impact on research, but still to do an EVA, any EVA, and get 40 plus hours of research is an amazing feat. So it's the testimony to the efficiencies that we're starting to gain, but also the time the crew's putting in to get things done. And in fact, I have to continually caution them not to work themselves to death. You know, this is a marathon on station, not a sprint like we used to do in shuttle. And so we constantly remind them, make sure that you're pacing yourself so that you're ready to go every day, as opposed to, you know, really kill it for a couple of weeks and then have a hard time recovering from that.
Warlocker, but during your increment, who's trained for the Big 12 repairs? Is it all 3 Chris plus Luca Parmitano and Karen Nyberg, or just 2 on the U.S. segment?
Yeah, so Chris, Karen, and Luca are all fully qualified for spacewalks, so all 3 of them are capable. That's correct. Yep.
Okay, we got time for one more. Go ahead, Robert.
Earlier this week, they announced that EarthCam was our ISS EarthCam was going to be renamed Sally Ride EarthCam. Is that your one continuous science student outreach science experiment, or do you have others that are running continuously on the space station through expeditions? And does student experiments count into the science total when you count up hours?
Oh gosh, yeah. There are a couple of education payloads that are ongoing, that have been ongoing for years over station. One of them is the ISS ham radio, where the crew can connect with students across the globe formally to call down using ham radio, and the students get to ask the crew questions, which is a really important part of it. You know, there's always some kind of ongoing competitions for students, especially through the NanoRacks experience and the studies for the student experiments designed for spaceflight. It's an ongoing process. I can only think of those 2 at the top of my head, but there's quite a handful that have been continuous.
In one program we don't talk about, and we really should do a better job. We have a growing program we refer to as HUNCH, and I can't tell you what the acronym stands for today, but it involves primarily high school, I'll say juniors and seniors. I don't think it's limited necessarily to just junior seniors, but high schools and some colleges and junior colleges, where we actually work with the students to build hardware for us. And generally speaking, largely they build training hardware for us. But there have been simple, even flight items they have built for us. And this has been growing for years now. And I don't remember the number off the top of my head. I've signed a number of agreements in recent months, but it's grown. It started off as 1 or 2 or 3 schools, and mostly in the Houston area, to, I don't know the exact figures, but I bet we have 25, 30 schools involved now across the country. And it's an amazing program because it introduces kids to the practical application of the science and engineering and math kind of things that we're trying to encourage in kids today. It's been a great program from the standpoint of getting interest, because you know, if anything like me, it's great to go do the math and stuff, but it's where you get to get your hands on hardware, build hardware, see the fruits of your labor, that you really get energized, and you really learn about the practicality of the analysis that you've been learning, or the techniques that you've been learning. So that's been a growing program for us, and we don't talk much about it because it's not too much of the hardware goes to flight, and if it does, it's not giant. I mean, they built bags and some onesie twosie other items on orbit, but it's a really big deal to the kids, and I think it's helping grow or instill the interest level in the students when they get to do something practical with what they're learning.
And might I add, if there's a minute, you know, space station research has actually touched about 42 million students worldwide. I mean, and of the U.S., that would be about 30 million in the U.S. So that's just since 2000. So whether it's K through 12 or undergraduates or graduate students crunching numbers, there's some kind of participation in just about every investigation that's happening on station for student involvement.
Okay, with that, we're going to wrap it up. Let's take a look at our coverage that is planned for Tuesday as Luca, Karen, and Fyodor get ready to launch to the International Space Station. Our live coverage here on NASA television begins at 2:30 p.m. Central Time. Launch will take place a little more than an hour after that at 3:31 p.m. Central Time. That is going to be bright and early at about 2:31 a.m. there locally in Kazakhstan. Be a long day for those folks down there. Docking coverage begins at 8:30 p.m. Central Time, with docking taking place at 9:16 p.m. And then we'll have a separate broadcast as the hatches are opened at around 10:30 p.m. Central Time, the actual hatch opening at 10:55. For all the latest, just log on to the NASA website at nasa.gov/station. We thank you again for joining us.